Introduction to equations of lines. So as way of review, let's complete the following table. We'll rearrange the polynomials in descending order of degree where necessary. So this is of degree 1. The leading coefficient is 4, and the constant term is -3. This equation is of degree 2. The leading coefficient is 2, and the constant term is -5. This needs to be rearranged. This is of degree 5. The leading coefficient is -5, and the constant term is 4. An example of a polynomial expression, each of these guys are polynomial expressions, but this is a polynomial function. Y equals, basically when you set it equal to, y equals, or f of x equals. For the rest of the unit, we will be determining equations of lines and graphing them. A linear function is a special type of polynomial function, but what does the equation of a line look like? We know what lines look like. What is their equation? The table below shows some polynomial functions up to and including degree 3. Complete the table. Use your calculator with the following window to complete the last column. Okay, so y equals 5. The degree is 0. Leading coefficient, 0, and the constant is 5. This is of degree 1. Leading coefficient is 3, and the constant is 1. This is of degree 2. Leading coefficient is 2, and the constant is 2. This is of degree 3. The leading coefficient is 4, and the constant is 2. So we're going to go to our calculator here. I'm going to slide this guy over. We'll turn this on. Set the window -8 to 8 by 1. And for the y values, y min -8, y max 8, and y scale 1. We have y equals 5. Now let's do these one at a time just so we can see what that looks like. Put a check mark in this column if the graph is a line. So the graph of y equals 5 is a line. How about y equals, so let's add to that. We've got 3x plus 1. Graph. Alright, that's also a line, so we can put a check. And let's go. We'll keep in mind these two. We'll add y equals 2x squared, 2x squared, minus x plus 2. That's this new guy here. That is not a line, so no check there. And lastly, 4x cubed, 4x. This is how we're going to put in the cubed. Oops, and then we're going to kick forward 1, minus 3x squared plus 2. Graph. And we can see that's drawn, and the added one is also not a line. As you can see, a linear function is a polynomial function that is either degree 0 or degree 1. What kind of line did the degree 0 polynomial make? Well, it was this line here. It was a horizontal line. So horizontal. And we know something about those. We know what their slopes are, right? Slope 0. Horizontal line. Ooh, horizontal lines. Horizontal lines are defined by degree 0 polynomial equations. They're also called constant polynomials. They're of the form y equals k, where k is just a value, a constant. Sketch the graph y equals 3 and y equals -3 using your calculator. Okay, let's go to y equals. We'll change this to a 3. We'll go down here. Let's just go and clear everything out, everything else out. And we'll go to here and we'll go y equals -3. And let's graph those. So first one graphing is y equals 3, and there's graphing y equals negative 3. Label each equation, each line with its equation. Okay, so let's draw this. Okay, most important thing, right? Put arrows. Can't tell you the number of math 20s that lose marks because they don't put arrows on lines. If they're lines, they go forever. Okay, and this is y equals negative 3. Look at the table of values generated by the calculator. Okay, so we go second function graph takes us to the table. And you'll notice that all the values are 3 or negative 3. For y1, they're all 3. For y2, they're all negative 3. How do the y values in the table of values relate to the equations? Well, they're the same. They are all 3 or all negative 3. Without a calculator, draw graphs of the line y equals 5. Well, there we go, y equals 5. And y equals negative 1. I just can't draw a straight line. Y equals negative 1. On the same grid. Check. Label them. Check. Oblique lines. Oblique lines are lines that are neither horizontal nor vertical. In general, all oblique lines are degree 1 and can be expressed in the form y equals ax plus b, where a and b are real numbers. Right? That is to say that a and b belong to the set of real numbers. And a is not equal to 0. If a is equal to 0, then this term is wiped out, and we get y equals b, which is a horizontal line. Okay, recall that if a line is in the form y equals ax plus b, the leading coefficient is a, and the constant term is b. Let's look at some linear functions that are in the form y equals ax plus b. Without a calculator, fill in the table of values and plot the points on a grid. Okay, 0. Negative 3 times 0 is 0, plus 5 is 5. Negative 3 times 1 is negative 3, plus 5 is 2. Negative 3 times 2 is negative 6, plus 5 is negative 1. Negative 3 times 3 is negative 9, plus 5 is negative 4. Okay, and let's plot those points. Okay, 0, 5. 1, 2. 2, negative 1. 3, negative 4. Now those are points. Points help us in drawing the line. And a line needs arrows on either end to be a line. Y equals 1/4 x plus 2. Now, here's the thing. When you're choosing values of x, so here it really doesn't matter what you take. You can multiply anything by negative 3. When we're multiplying by 1/4, you get to choose your values, so choose wisely. Don't choose numbers like 3, because you'll end up with 3/4. Choose numbers that are multiples of 4. So 1/4 times negative 4 is negative 1, plus 2 is 1. 1/4 of 0 is 0, plus 2. 1/4 of 4 is 1, plus 2, which is 3. So we have the point negative 4, 1, 0, 2, and 4, 3. I'm going to draw a line, so those points are in a straight line. Draw a line, which should be a line you use the edge of your thing. I don't have one, I'm freehanding it, and I'm not a good freehand drawer. Negative 4 plus 3 is negative 1, negative 2 plus 3 is positive 1, 0 plus 3 is 3, 2 plus 3 is 5. So we got 4 points, negative 4, negative 1, negative 2, positive 1, 0, 3, 2, 5, and let's try and draw. And it's try, because all I can do is try. And there's our line. Okay, so what I want to see from you, especially on a test, is make sure that those points are accurate. And then use the edge of your calculator battery window, or bring a ruler so you get a decent line. If you remember from the previous unit, relations and functions, for a linear function, a constant change in the independent variable, that's delta x, will produce a constant change in the dependent variable, delta y. And, remember, delta y over delta x, and delta y. So this is the rate of change. Oops, I lost my pen. The rate of change, which is it's also the slope. It's the change in the dependent variable over the change in the independent. Independent, or rise over run. For the following linear functions that are in the form y equals ax plus b, complete the following table by looking at their graphs. Well, first, leading coefficient and constant terms, we don't need to look at graphs. Slope, rate of change, looking at their graph. Okay, so let's go back and look at their graphs. Okay, negative 3x plus 5. Let's take a look at the rate of change, right? The slope. So we go 1, 2, 3 down, and 1 over, right? 1, 2, 3 down, so negative 3. While we're at it, let's do this one. This is up 1 over 4, and this is 1, 2, 1, 2 over 2 up 2. So this slope is negative 3 down 3 right 1. This slope is 1 over 4. And this slope is 2 over 2, which is 1. Okay, so let's go back here. So the slope, the rate of change, was negative 3 over 1. This was 1 over 4, and this was 2 over 2, which was 1 over 1. Y-intercept, where the graph intersects the y-axis. Okay, let's go back here and find the y-intercept. So negative 5, positive 2, positive 3. Remember those numbers? Positive 5, positive 2, and 3. All right, one more time. Yeah, there we go. So positive 5, positive 2, positive 3. And wait a sec, we're seeing the same numbers appear here. So as you can see, for oblique lines in the form y equals ax plus b, the leading coefficient a is equal to the slope. And the constant term b is equal to the y-intercept. What letter did we use for a previous lesson to represent slope? We used m. Since a is slope, we replace this letter with the letter used, so a, we replace with m, and we get y equals mx plus b, and that is our first equation for a linear function. Slope y-intercept form. For equations of lines in the form y equals mx plus b, m is the slope. And b is the y-intercept. Now, these are, of course, exercises for you to do. But I need a key for these, so I'm going to have to do them. And so you should pause now, and then you could check your answers with this, or check your answers with the online. But if you need to see an answer being done, then come back here. I'm just going to kind of whiz through these. Use slope y-intercept form to write the equation in line with the slope of 1/2. Okay, so slope y-intercept form looks like this, right? Formula, substitution, the slope is 1/2, and the y-intercept is -3. So y equals 1/2 x minus 3. Use the slope y-intercept form to write the equation of a line. Again, slope y-intercept form, right? That's a specific form. It has a formula with a slope of 2 and a y-intercept of 0. So I don't need to write plus 0. We just leave it as y equals 2x. Y equals slope of 0. So we would just write y equals 7, and we know what that looks like, right? That's just a horizontal line. Complete the following table. Use slope and y-intercept to sketch each line. Ooh, I can use different colors. The slope is 2, the y-intercept is -7. Okay, so what you do, you start off by finding, hang on, let me just see if I can tweak this down just a touch. So you find the y-intercept, slope of 2. Okay, remember, slope of 2 is 2 over 1. Go up 2 over 1. 2 over 1. I do as many as I can. And then if I've done them right, they should all be on a straight line. Okay, and I fill the grid with the line. Okay, and then let's label that A. Okay, no, it's not that good. The slope is -3/4, and the y-intercept is 1. -3/4 says go 1, 2, go down 3, right 4. Go down 3, right 4. I can't quite get there. But it also says go up 3, 1, 2, 3, and left 4. Go up 3 and left. Okay, I won't do it either. And we draw the line. And we put arrows on both ends. And we label it. That's B. Slope is -1. And the y-intercept is -4. So we start with the point that we know, which is the y-intercept. Slope of -1 says go down 1, right 1. Or it says go up 1, left 1. And draw the line, put arrows on both ends, and that's C. Y equals 4, so the slope is 0, the y-intercept is 4. This is a horizontal line drawn where y is equal to 4, and that's D. And E, y equals 5x, the slope is 5, the y-intercept is 0, so from 0 we have a slope of 5, right, which remember is 5 over 1, so that's up 5 over 1, but 5 over 1 can also be written as -5 over -1, saying go down 5 and left 1, and really I'd like to see a few points on here, right, better. See, 2 points you can draw any straight line, regardless. If you put 3 points, then they need to be in a straight line for you to draw the straight line. Okay, and we'll go back. Number 5, use the graphs at right to complete the table below. So now we're going the other way. Now you'll notice we didn't draw arrows, but our graphing program isn't good with arrows, and that there should be arrows on there. But A has a slope of 0 and a y-intercept of 6. Remember, the equation of the line in slope-intercept form is y equals mx plus b, so this is y equals 6. B has a y-intercept. That's the first thing I'm really going to identify, right? The y-intercept is -5, and I need the slope. So I need to go along the line and find a point where it goes through. And then I can count 1, 2, 1, 2, 3, 4. Well, actually, I could have used this point then. Up 1 over 2. The slope is 1/2. It's positive because the line rises to the right. Y equals 1/2 x minus 5. C. Y-intercept, -1. Slope from there, I just go try and find a point. Looks like here. This is a negative slope. 1, 2, 3, 4 down. 1, 2, 3 over. -4 over 3. Y equals -4/3 x minus 1. D. Y-intercept is 5. Slope. Well, it looks like a point there, so I'm going down 6 and over 2, which means I could have just gone 1, 2, 3 down and over 1. It's a negative slope. 3 down, 1 over. Y is equal to -3x plus 5. And E. Here's E. Goes through 0, so y-intercept is 0. Slope looks like 1, up 1 over 1. So this is just the line y equals x, a line we will come to know a lot in the future. And I think that's it. And that is it. And then there's some homework to do on top of this. So we are done.